Now this exercise illustrates the concept of dilution, and we can prepare a dilute solution from a concentrated solution. So question, we have a concentrated H2SO4 solution, and if we add water, we can convert this into dilute H2SO4. Now question says how many milliliter of 3m H2SO4 are needed to make 450 ml of 0.1 m H2SO4. So finally we have to prepare 450 ml H2SO4 and concentration is 0.1 m. Initially we have 3m H2SO4, and what is the volume? Let us say volume is, we have to take V liter or X liter. So volume we have to take X liter. Now how we'll proceed? What should be the plan for this problem? You see, I have a concentrated H2SO4, add water, and I have a dilute H2SO4. Moles of H2SO4 that is in concentrated solution should be same as moles of H2SO4 in dilute solution. So we have to apply this idea, that is moles of H2SO4 in conc solution, that is concentrated solution, is same as moles of H2SO4 in dilute solution. So we have to use this idea. So let us say how we can proceed for solution. So initially find moles of H2SO4 in dilute solution. So moles of H2SO4 in dilute solution, and this is equals to volume into molarity. Volume is 0.45 liter and molarity is 0.1 m. So this is equals to 0.045 moles. So this is the moles of H2SO4 in dilute solution. We can calculate moles of H2SO4 in concentrated solution, and this is equals to molarity times volume. Molarity is 3m and the volume is x liter. So 3 into x, this is final moles. Now we can equate these two because initial number of moles of H2SO4 is final number of moles of H2SO4. So from here we can calculate x, and this is 0.015 liter, and that is x is equals to 15 milliliter. So we have to take 15 milliliter of H2SO4, add sufficient water, so that finally we have 450 ml of dilute solution. So we have to consider 50 ml of concentrated H2SO4. So we have to take 15 ml of conc H2SO4 solution, that is concentrated H2SO4 solution. Now let us do this practice exercise. Basically we have first one, what volume of 2.5 m lead nitrate solution contains 0.05 mole of Pb2 plus. So let us discuss part A. So we have lead nitrate PbNO3, and this in solution it can dissociate, it can give you Pb2 plus 2NO3 minus. We have been given lead nitrate concentration, that is 2.5 m. We have to calculate what is the volume of lead nitrate that should be taken so that it can have 0.05 moles of lead nitrate, that is Pb2 plus. So idea is simple. We can calculate moles of Pb2 plus because PbNO3 contains Pb2 plus. So moles of Pb2 plus here is equals to moles of Pb2 plus here. That is 2.5 into x. This is equals to 0.05 0.05. So x is equals to 0.05, this divided by 2.5, and we can calculate in milliliter, and then we have to multiply this by 1000. So this is 0.05 divided by 2.5, and this multiplied by 1000. So this is 20 ml. So we have to take 20 ml of lead nitrate solution. Now let us discuss part B. How many milliliter of 5 mK2Cr2 solution must be diluted to prepare 250 ml of 0.1 m of the same solution? So I have a K2Cr2O7, that is conc, and if I add water we can have K2Cr2O7, and that is dilute. In the first case it says 5 m solution, and we have to find what is the volume of K2Cr2O7 that should be taken. So let us say volume is x liter. Now K2Cr2O7 dilute, that is 250 ml 0.1 m. So this is 250 ml 0.1 m. So we have already said moles of K2Cr2O7 in conc solution is same as moles of K2Cr2O7 in dilute solution. Moles here is 5 into x, and moles here we have 0.1, and we have to consider milliliter in liter, so 0.25. So x is equals to 0.1 into 0.25, this divided by 5, so we will have this 1.1 into 0.25, and this divided by 5, so this is 0.005, that is basically 5 ml, so 0.005 liter, or we can convert into milliliter, that is 5 ml. So we have to take 5 ml of K2Cr2O7 solution, that is a concentrated solution. Let us discuss part C. Now this says 10 ml of 10 ml stock solution. A stock solution is generally concentrated solution, is diluted to 250 ml. What is the concentration of resulting solution? So we have a NaOH concentrated, that is a stock solution. A stock solution are generally concentrated solution. Now this is converted into NaOH dilute, and NaOH concentrated solution has a 10 ml 10 m. So this is 10 ml, concentration is 10 m, and NaOH dilute, basically this has 250 ml, and let us say concentration is x, 250 ml, and we have to find concentration, that is molarity of NaOH. Let us say molarity is x, so molarity is xm. So we can find moles of NaOH here, that should be moles of NaOH here. So here we have 10 into 10, and we have to consider milliliter into liter, and this is 25 ml, that is 0.25 liter into x. So from here, so x is equals to 10 into 10, 100 into 10 power minus 3, and this divided by 0.25, that is 0.1, and this divided by 0.25. So we can say this is 0.1 divided by 0.25 divided by 0.25, this is equals to 0.4. So molarity is 0.4 m. So this is the final molarity of NaOH. So you see initial molarity is very high, 10 m, and the final molarity is very low, that is 0.4 m. So this is a dilute solution, so I can say molarity of dilute NaOH, molarity of dilute NaOH, this is equals to 0.4 m. So in this lecture or in this practice exercise, we have discussed how to calculate problem related to dilution. So you have been given concentration, you have been given another concentration. In those two concentration you have to equate number of moles, that is mole remains constant in dilution. So only important point we have here, moles of solute remains constant during dilution. So this is the only important point we have.